Hello friends, Dr. Patterson again. In this video, I am going to show you, if you've bought one of these boards, how to program Lab 1 using Python. I'm going to tell you right now, I have not had a bunch of experience with CircuitPython, which is the port of Python that works with the board I'm going to show you. Um, and not only that, I've only done a few medium-sized projects in Python. So, and that was a while ago. The rust has collected. I am super rusty in programming in Python. So this might be the equivalent of like a 20 or 30 grit sandpaper. It's going to be really rough. We're going to try it. All right. So this is the Mu editor. Really, it's where you can type in your code into a script that is saved onto the board. And then you actually get the REPL down here, which allows you to see essentially the serial communication, or this, we've got the serial monitor. It's essentially the same serial type monitor that we had in Arduino. We get that same kind of feedback here at the bottom. The cool thing here is that you don't have to just put your code up here. You can also test code down here. So it's more like the MATLAB interface where I can use the command window to actually test out different commands. I've got that ability now with Python. And so it kind of like puts the two together. I can write that code and have it run on the board by itself, just with a power supply. I don't have to have it hooked up to the computer. And I've got the kind of interpreter approach where I can run commands like on demand essentially. So it's kind of nice. At least that's why I'm interested in it. The board that I'm using is the Adafruit Metro ESP32S2, and the board itself, this smaller board that sits on top is the ESP32S2, and it incorporates Wi-Fi and Bluetooth all on one device, and it's got, I believe, two processors at 240 megahertz. So it's substantially more, like a substantial amount of power more than what we get with the Arduino. And it's fairly easy to tie it in over Wi-Fi, which we're not going to get to today, but I do hope to show you at some point later this quarter. So things are a little different in this realm. We actually have to include libraries to do a number of different things. Where in MATLAB it's effectively like you create the Arduino class and you're going, right. You have to install some toolboxes, but really like it's all the stuff is there. Whereas in C, there are a lot of libraries that you have to include for any kind of expanded functionality. In Python, or in CircuitPython, you have to do it for even some of the basics. And so what I'm going to start with is import board, which is essentially like all the specifics for the board that we're using. And so it kind of like gives that gateway between the different types of boards that you can get. And I'm going to pause for a second because I'm going to show you the compatibility of different boards with CircuitPython. All right, so this is a list on the CircuitPython website where it shows all the different boards that you can use. And each one has its own essentially compiled version that you can load onto it. This board I thought was really nice because you just like tap the reset button twice. It actually shows up as a drive on your computer, and you have to drag a single file over and it loads it. And then you can start programming it in CircuitPython. So from that perspective, it's super easy to use, which is one of the reasons that I got this particular board. I've used some of the other ESP boards in the past with Wi-Fi, and including some where I had to actually solder wires on to even be able to program them correctly or more reliably anyway. So I wanted to go with something that was easier to use because that was a pain in the butt, or at least really annoying when I wanted to reprogram. So, like I said, the board essentially like lines it up so that you can call out different pins that are kind of universal between all the different board formats that you just saw. So we're going to import that so we can know the specifics there. And I could even say, now I want to create an LED or a variable that's essentially an instance of one of these input output pins. So I can say, or I don't even have that yet. I need to import also the digital IO library. And then I can say, now I'm going to set up an LED, essentially just like a pin. And I'm labeling LED because I'm going to do the first LED. And I'm going to say that the LED is equal to digital IO. And then on there, there's different methods as well. So digital in, out, and then I need to specify what pin it is. In this case, I want to do, so these pins, it's a little confusing because I've actually plugged them in exactly the same as I had on the Arduino board that you guys have with your kit, whether it's the Metro or this genuine Arduino one. The numbers on here do not match up with the numbers on here. I'll show you. So, but they are, when I call this, I'm actually going to say D2, or not D2 because that's a button, D4. That's actually on the Arduino board, that is pin 2, D2. No, I did that backwards. No, that is pin 4 on here. On this board, it is pin 9. So it's not actually 9, it's 4, and we can test that. And so now we can say, let's just turn the LED on, wait for a little bit, and then turn it off. So we can say, or we need to set the direction first. So we need to say LED dot direction is equal to, and then we do digital IO dot direction dot, and then we can specify input or output. So again, compared to MATLAB, slightly more complex, right? Because in MATLAB, we literally just said, I want to read from this pin. We didn't have to specify the pin. In C, we actually had to specify a pin mode, and then we could read from it. Now in Python, we're specifying a certain pin to address, and then we're telling it which direction. So it's essentially closer, or at least in the number of lines that we're using so far, closer to the Arduino C++. So then we've got the direction set, and we've set it to output. And so now we can toggle it on or off. And so we can say LED.value is equal to, say, 1, and then let's just leave it on. Cool thing about this, all I have to do right now is save. And if the board is hooked up correctly, oh, D4 is not defined. I can't do D4. I have to do board.d4. In theory, it's working. I wonder if these LED and resistor combinations are not going to work. Maybe my whole spiel was wrong. Oh, it turned on. That was the wrong one though. D. 4, 2, 3 are the switches. And then this yellow one goes up here. Checks out. If I say, maybe I can't use 1. If I say true. Oh, I saw it blink. Let's add in the ability to pause. Again, something that's easy to do in MATLAB, right? Let's go. Not there. Oh, we don't have, I didn't use any pauses. Oh, well, we can say pause and 1 second, right? And we know that that just pauses for 1 second. In C, we'd use the command delay and then a number in milliseconds. For Python, we can go back over and we have to import the time library. And then we can come down here and say time.sleep and tell it the number of seconds. Let's say 2 and see what happens. Oh, it turned on. Let's try that again. It turns on and it stays on for 2 seconds. We're on a roll. All right, so what we can do next to go or to keep in line with the tasks that I had set out, which let me pause and I'll pull those up again. All right, so task 1 is turn on an LED when one button is pressed and turn it off when the other button is pressed. So we need some way, just like we did in MATLAB, we need some way to loop around this. So we can say, while true, and then the loops look a little different. There's no parentheses. We just indent whatever's inside of there. There's some funny videos about do you use spaces or tabs? Should look those up. So we want to monitor a button. So we've got an LED, which we can turn on or off, which I have to use true or false for, not 0 or 1. So we've got those, but we need the 2 buttons. So we can say button 1 is equal to digital IO dot digital in out, and say for the board it's D2, that's our first pin. And then I can say B1 dot direction is equal, again, the digital IO dot direction dot input this time, not incremental encoder. And then do the same thing for the second button. And that would be on pin 3. So now we got the LED and 2 buttons. And then while true, we want to say if one button is pressed, yeah, the board's probably doing weird stuff right now because you can see it's throwing an error at the moment. It's still throwing an error. Yeah, we'll see. So if the button is pressed, turn it on. If it's not pressed, turn it off. Or if the other one's pressed, turn it off. So I can say if, and then right here I would say b1.value, and I'm getting back a true or a false value. And so I can use that directly to say this is just essentially the condition for that if statement. And then I can say on the next line, with that first button, I want the LED value to be equal to true. And then I can say else if, or just if, and do another if statement. b2.value, and then LED.value is equal to false. So same thinking as what we had in MATLAB, right? We had a loop that goes around the whole thing. We check the button with one statement. We set it equal to true if that button is pressed. If the other button is pressed in the second if statement, then we set that LED to false or 0. So let's save this and see how many errors we get. Oh my goodness. It works. This is my second CircuitPython script. My first one was, can I make this RGB LED blink? I'm congratulating myself right now with a golf clap. All right. The next one I'm going to do, because it's incredibly similar, at least from what we did with the Arduino side of things. If you remember, or if you watched that video, all I did was print the statement gong sound, or play gong sound, or play handle music. Like in MATLAB with task 3, it actually played the gong sound or played the handle music. So in here, instead of these LEDs, I can say, instead of display or fprintf, we can just say print, and then say play gong sound. And then here, I want to say print play handle music. And if I run that, then when I press this first one, nothing. Oh, something's going on. Not responding. I'll be back. Maybe. It won't let me pause. All right, I think what happened is I was spamming the monitor so much. Well, I know that's what happened because now that I put that 0.1 second delay in there, it works. But when I hold it down, I get multiple statements. So what we can do is I had to do this in C where I monitored the value, and I wanted the condition, I only wanted to go in there when it was actually like pressed down and not previously pressed. So I'm going to use that same logic here. I'm going to say previous button 1 is equal to, or sorry, nope. I'm going to leave that. Well, out here, we'll initialize previous button 1 is equal to false, and previous button 2 is equal to false. And then in here, it said current button 1 is equal to button 1.value, and then we can say if current button 1 and not previous button 1. Let's try that. Nope. It's the not symbol. Oh man. 1 second. Yeah, what you just saw was the accumulation of rust. Python rust. It's literally and not PV1. And then we'll grab current button 2. And then we can say here we want to do current button 2 and not previous button 2. And then at the end, which we can get rid of this delay now. We can say previous button 1 is equal to current button 1, and previous button 2 is equal to current button 2. See if it works. Oh, it's only doing it once. Hey. Got that one down. Now for the more complex one. So the next one was incrementing the LEDs upwards. So I stayed away from arrays so far. So this is gonna be a lot of commands right next to each other because we have to set one, we have to do all the names for that, and it's 4 through 9. So let's get all those set up. Oops. And we can label these. Oops. Six LEDs. Got the direction set. And then we want to use an increment. And I think the easier one, to be honest, the one in C was easier to understand because I didn't try to combine the variables. So let's say we've got a delay of 1000 to start, and our increment will be equal to 1 initially. So we'll count upwards. And then we want to say, can ignore this. We just want to say if v1.value. So if one button is pressed, the increment goes to 1 and delay goes to 1000. So 1 second count upward, or sorry, it's actual like integer values for 1 second, or not integer values, but sleep 1 is sleeping for 1 second. And then for button 2, we can say increment is equal to -1 and delay is equal to 0.5. And then in here, we want to say what LED is it addressing? Oh, golly. How can I do this? This is ugly. Because of how this is set up, I can't do it the same way I did in MATLAB. And I can't really do it the same way I did in C. And I'm also very unfamiliar if these values are set to constant values. So we can make, what can we do? An ugly long if statement. Sure, let's do it. So we also need the time, because if thinking about what we did in MATLAB, we started a timer, right? And then we kept track of the time. In C, let's see, what do we need? Let's say time.sleep1. This time, wonder. Let me increase this for you guys. Time. Makes sense. Current time in seconds since January 1st, 1970. Prefer the time since the program started, but maybe that's fine. Mark time. Nope. Let's go with time.time. Current time in seconds. It's an integer value. I don't really want to deal with structs because I feel like that's too... I don't want to move too fast for you guys. Let me ponder on this for a moment. I jumped the gun. I think this monotonic, time.monotonic is what we're looking for. So let's try that. So we can sleep for 0.1 seconds, and then we can print time.monotonic. I think that's up. Oh. That's pretty cool. That's exactly what we need. All right. So we can say, just like we did before, previous time equal to time.monotonic. Nope, don't need semicolons. And then inside the loop, just looking back to what I did in MATLAB, trying to translate it directly. If the previous time plus the increment is less than the current time, so if previous time plus absolute of the increment, which we don't want that. We just want to add the delay. That's what we're trying to do there. Is less than time.monotonic. Then colon, then we grab the new time. So previous time is equal to time.monotonic. And then we say, again, looking at this, super convenient there. Gosh, there's got to be a better way to do it while still not using arrays. But we're going to do this. So we're going to say if, and we're going to track an LED pin value here. Equal, we'll start it at 4. If LED pin equal to 4, then what will we do? Yeah, and the increment. And increment is less than 0, then we do nothing. So that one's kind of gratuitous. We don't need it. Well, we do. Let's put that in parentheses. And we'll say or LED pin equal to 9 and increment is greater than 0. So if those are the two cases, we don't want to turn the LED off. We just want to leave it on. And then going to do nothing else. Oops. There we go. And then in the else statement, we'll say, if pretty much, this is the annoying thing, this is why I kept like waffling on what to do, is pretty much no matter what, we want those LEDs to turn off. And then we would need another one up above, which is why I'm wondering if what these constants are. If we can specify just a single number. Let's try, nope. Because we're actually grabbing the pin object. What is that? Let's look at that. Digital I/O. Digital in out. It passes back a pin. And not helpful. I wonder if, what does the pin have? Not helpful. All right, let's do it the way I really don't want to do it, which is if LED pin is equal to 4, then we're going to say LED1 dot value equal to 0 or equal to false. We could do a switch case. I know some of you are not familiar with that. So we're just going to do it the ugly way for now. I told you this is going to be 20 grit sandpaper. All right, so it'll turn it off. And then sadly, after these, we want it to, after you turn the pin off, then going back, we want to increment the LED pin and do the min-max function that we had in the other two, and then write to the new one. So we're going to LED pin is equal to LED pin plus increment. And then we'll do the LED pin is equal to that same exact thing. And then we'll grab this and we have to put it again. Except we wanted to say true. Oh, we've got errors. Line 45. What's wrong with my if else? This is sad to me. Give me a second. Totally because it was an empty if statement. So if we change this and said the opposite of this, so we're saying if that or the other one, then we do nothing. Which means that we'd have to say if not the first one and not the second one, then we turn the LEDs off. So we can say if not this and not this, and get rid of the else. No errors. It's counting upwards, which is fantastic. Oh, counting down. Oh my gosh, it works. It's some of the, I'm not gonna lie, some of the ugliest code I've seen in a while, and can confidently say some of the ugliest code I've made in a while. But it works. So that's the 3 tests from lab 1 for week 1. Hopefully you've enjoyed these videos. I do recommend, I'm interested in trying to pick up like one more Python because it has been a while since I've done much of anything with it. And 2, I'm really interested in the idea of trying to unify the languages that we teach to you guys as students. And so like the idea of using Python for what you currently do in MATLAB, and then also be able to interface with a microcontroller using Python. That's personally interesting to me. We'll see if we can make that a reality or not. But this is what we'll be doing each week. Is I'll be making videos for the 3 different languages for the lab tasks, assuming that it's not one of the simulator heavy weeks, which you'll see those when we get there. But that's all I've got for this one. See you in the next video.